Hello everyone, welcome back to Mind Maths with Amina. Today I'm going to continue solving the worked examples given in the Statistics 1 study guide provided by University of London for their EMFSS courses. This is chapter 4 called Random Variables, the Normal and Sampling Distributions. Okay, suppose a random variable x follows a normal distribution with mean 10 and variance 4. So the mean is 10 and variance is 4, therefore the standard deviation is going to be 2. Find the probability of x being greater than 13.4. So in order to convert this into standard normal, we're going to have to do this. So x minus a 10 over a 2. Okay, so we are interested in the probability of x being greater than 13.4, which is the same as z being greater than 13.4 minus a 10 over a 2. We take our calculators out and we get probability of z being greater than a 1.7. Okay, this is the same as 1 minus the probability of z being less than equals to 1.7. This is 1 minus the probability below the curve when x is equals to 1.7. Okay, let's find 1.7. Here it is. So 0.9554. 0.9554, which is a 0.0446. So there's a 4.5% chance that this random variable is above 13.4. Okay, if you want to give yourself a visualization of this, you can also do this. This was the actual and this is the normal, standard normal. So the real was centered about 10. This is a 0 and this is a 13.4 and this was 1.7. So the shaded region for the z variable, x variable is the same as when we convert the variable x into z. So these two shaded regions give us the same area. Okay, part B. Part B says find the probability of the random variable x being between 8 and 9. Okay, greater than 8 and less than a 9, we'll have 8 minus 10 over a 2. This also the same, 10 over 2. Okay, this becomes a minus 2 over 2, which is a minus 1. This becomes a z variable and we have a minus 0.5 here. Okay, so to give ourselves a good idea, it seems as if this is the shaded region that we want the area of. Okay, because this is a 0, this is a minus 0.5 minus 1. Remember the symmetrical nature of the normal distribution. This is going to be the same as the probability of z lying between 0.5 and 1, because the shaded region over here is going to be the same as the shaded region here. Okay, this is simply the probability of z being less than 1 minus probability of z being less than 0.5. So probability below the curve when z is equals to 1, probability below the curve when x is equals to 0.5. Okay, so 1 and 0.5. A 1, 1, 1, 1, where is it? This is a 1. And 0.5, where is it? Over here. So an 8413 and we have a 6915. Okay, oops. So 8413 and a 6915. And this becomes a 0.1498, which is almost a 15%. So 15% of the population lies in this interval. Okay, next. Find the value of a such that, okay, this is kind of a strange question. 10 minus a x 10 plus a, and the probability is given as 95. So this should be fun. It could be fun or embarrassing. Let's see. Let's take it step by step. Okay, so this was part B. The first step will always to convert it into z. So we'll have a 10 minus a minus 10 over a 2. We're basically doing the same over here. 10 minus 10 over 2. Probability is the same. Remember, the standard normal distribution gives us the same area as the original distribution. We're just continuing the, we're just basically changing the variable. Okay, we'll get probability of minus a over 2. This becomes a z, and an a over 2. And we have a 0.95. Okay, so it seems that the area fully below the curve is 100%, right? So it should be something like this, 95. Okay, so let me shade this whole shaded region is 95%, which means that this is going to be a 2.5%, and this is going to be a 2.5% due to the symmetrical nature. And the value over here is a over 2 minus a over 2. Okay, so what we can do is that we can actually look at the formula sheet and see the end, see table 5 actually, that'll be better. If you see table 5, it actually gives us the area on the upper, it's basically the upper tails area. So it tells me the probability of the area assigned, and I basically it's going to give me the value of x now instead. So for instance, over here, this is given. So the area is given and you find the z value. But what we were doing before was that we had the value of z, this was given, and we were looking for the probability. We were trying to find the area. So now we have the reverse order. I already know the area. I know the area here. Let me shade it. And I need to find the probability. Let me write this out actually as a tip. When you know the probability and need to find z value which corresponds to it, then use table 5. Table 5. Okay, so we want a 2.5%. Okay, so a 2.5 is right here. Percent. It's given as a percentage, okay, because it's dividing it by 100 means a p%. Okay, so a 2.5% is a 1.96. So it tells us that this value should be a 1.96. Okay, so we have a over 2 being equals to 1.96. Therefore, the value of a is going to be 3.92. Okay, I've opened up my calculator on my phone. So you'll always need a calculator when you're solving questions in statistics. Okay, find the value of b such that this holds, because it's actually the same question, but they've just changed this here. Okay, 99%. So we can just do this faster. Okay, a 10 minus a and a 10 they actually wrote b, right? Plus b is equals to now a 99%. So this becomes a minus b over 2. This converts into a z, and this is a b over 2, and we have a 99%. So if the middle area was all of this shaded area was 99%, we have a 1% which is left over. So a 0.5% will go on the right side, and a 0.5% is going on the left side. So we want to search for a 0.5% now, which is this. So a 2.5758. Okay, so this tells me the value, the z value over here. So now we have a b over a 2 should be equals to a 2.5758. Therefore, b is equals to a 2 multiplied by 2.5758, which will become a 5.16. Okay. Part D. How far above the mean of the standard normal distribution must we go such that only 1% of the probability remains in the right hand tail? Okay. Right hand tail. Let's give ourselves a visual. So they want us to find some value x so that we have 1% area over here, and actually we don't know how to get that, but we do know how to get the value of z. So let's first find the value of z, and then we can just match it. Matching is actually a bad word, but we can just basically compare 0. Okay, we know that z is equals to an x minus mean over the standard deviation, which was a 2, right? So if I find this, I'll be able to find x, right? Let me confirm the question. How far above the mean of the standard must we go? Okay, in terms of that, I think it's just asking for the standard normal, so it just wants this. Okay, a 1%. So a 1% is over, where is it? Over here. So 2.3263. Okay, so z is equals to 2.3263. So if we have the value of z, we can find the value of x, which is going to be 2 multiplied by 2.3236 plus a 10. So it's a 14.6472. So the answer would be, if this is a 14.6472, the difference between these two is how many units? It's a 4.65. Okay, so the answer is that it is 4.65 units above the mean of 10. Yeah. Okay, next part. How far below the mean of the standard normal distribution must we go such that only 5% of the probability remains on the left hand tail? Again, this is the same question. It's like on the same pattern as part D, but right now we're on the negative side. Okay, so I always like giving myself a visual when it comes to anything in statistics, because it's always helped me understand better. Okay, this was 10, this is 0, and it said only 5% remains on the left hand. Okay, so only 5% has to remain. So this shaded region is a 5. So this is a 5. And therefore over here we also have a 5%. Okay, due to the symmetrical nature of normal district standard normal, this shaded region is the same as this shaded region. So let's find the value of z here. Let's look at 5%. We have a 1.6449. Okay, so this is going to be a minus 1.6449. So the corresponding x value, okay, z is equals to x minus 10 over 2. So this is a minus 1.6449 multiplied by 2 plus a 10 is going to give me the value of x. And therefore that's a 10 minus a 3.2998, and that becomes a 6.7002. So it means that we are almost, what's the gap then? If this is 6.7002, it's a 3.3, let's just approximate it, units below the mean of 10. Okay, we've done this question. Let's move on. Your company requires a special type of light bulb which is available from only 2 suppliers. Okay, we have 2 suppliers, supplier A and supplier B. Okay, so the mean lifetime is 2000 hours and the standard deviation is a 180 hours. Okay, so that means the Z distribution will be converted as X of company A minus 2000 over 180, because the X being the lifetime of this type of bulb follows a normal distribution with mean 2000 and a variance 180 square. Okay, what about supplier B? Supplier B, it says that the mean lifetime for supplier B is 180 hours, 1850, sorry, and standard deviation of 100. Okay, standard deviation of 100 hours. So basically the lifetime of this company of each bulb is 1850 and 100 square. Okay, so when we convert it into the Z normal, we're going to take XP minus 1850 over 100. Okay, the distribution of the is normal. Okay, your company requires that the lifetime of a light bulb must not be less than 1500, all other things being equal. Which type of bulb should you buy? Okay, let's see the probability of the light bulb that is provided by company A. It's a lifetime exceeding 1500 hours. So let's see the probability. When we convert it into the Z normal, we'll have a 1500 minus a 2000 over a 180. We take out our calculators and we make this calculation and we'll get a minus 2.78. We need positive values. We're going to use the fact that area under the curve is 1. So, okay, now we can use the statistical table and see the area below the curve when x is equals to 2.78. Okay, 2.78, 2.78, 99728. Okay, 99728. Okay, and this is going to be oops, I think I made a mistake here. Oh, this was this shaded region. Oops, my bad. Then this should have been actually, this is the same as probability of Z being less than equals to 2.78. Okay, I'm glad I realized my mistake. Okay, so then there is a 99.73% chance that the lifetime of a bulb that belongs to company A will exceed 1500 hours. Okay, what about company B? Okay, so when we convert this for company B, we'll have a 1500 minus 1850 over 100. We take out our calculators and we see what that number is. It becomes a minus 3.5. Okay, so it's this shaded region. This is a minus 3.5. So we want to find this shaded region. We're going to use the symmetric property. We're going to say this is the same as Z being less than equals to 3.5. And then we're just going to look at the statistical table and see 3.5. Okay, we don't have a 3.5. We have a maximum a 3.3 on this table. So we can, oh, actually there is 3.5 down here. 3.5. Okay, so a 9998. 0.9998. So there's a 99.98% chance that this light bulb is going to last more than 1500 hours. Therefore, you should actually choose company B because chances are higher over here. This has a 99.98 and this is greater than 99.73%. Okay, another thing that I wanted to say, that if you're finding all of this statistical tables like hard to read, you can also use Excel to find the probability. For instance, you can use the command norm. It stands for normal, S stands for standard, and DIST stands for distribution. Then you can write whatever, like Z value, for instance, a 3.5, and 1, which stands for, yeah, this is the true value, and then it's just going to give you the answer. Excel will give you a 0.9998 to this. And if, for instance, you want to find the probability, then you take the inverse. So for instance, if I write the probability 0.9, so it's going to tell me, I think it's going to tell me the value of Z when we have a 90% area below it. Yeah. So if, for instance, in this case, I have the probability and it's going to give me the Z value. So I'll get the corresponding Z value. Okay, which is actually going to be, let me just write it down. 90 means a 10%, 10%, 1.2816. Okay. 1.2816. So so these are two. If you have the Z value and you want to find the probability, you can use this formula, which is the same as using table 4. However, if you have the probability and you want to find the Z value, then you can basically this course sort of corresponds to table 5, but table 5 actually shows the upper tail probability, whereas Excel requires the lower tail. But you get the gist, though, that in this case you give the probability and you find the Z value. Okay, moving on. Next question. A normal distribution has a mean of this. Okay, mean of 40. And if 10% of the distribution falls between the values, what is the standard deviation? Oh, they haven't given us the standard deviation. That's unknown. Okay, so we'll have to think about this one. So the probability of X lying between 50 and 60 is 10%. Okay, so that means a 50 minus a 40 over the standard deviation. We get a Z value, 60 minus a 40 over standard deviation. Okay, and this is a 0.10. So we get a 10 over this, and we get a 20 over sigma. Okay, so basically we know that since the mean is at a 40, we're on the right side. Okay, that's one hint we have. And we know that the shaded region in between, this shaded region, it's telling us that the area is 10%. So this means when I'm converting the X distribution into the standard normal, I'm going to have 0 here, and I'm going to get some 10 over sigma and a 20 over it's called standard deviation, and the probability is again a 10%. Okay, so what we need to find is we know the probability, so therefore we just need to find something. Okay, if I write, there's one option that I use in the Excel. I'll say it's normal standard distribution, and I know if I plug in 20 over sigma comma 1 minus normal standard distribution, and the other Z value is actually a 10 over sigma, then the answer should be a 0.1. Okay, so I can either do this, or I think a better way perhaps would be to search for values in the statistical table which are above 0, and as you can see, if this is an x, this is twice its amount, right? So what we can see is that I need to search for a value. Let me erase this. We need to search for values in table 4 such that one is the half of the other. Okay, but we also, this is kind of tricky because, let's see, if I take this value, okay, as suppose a 2.5, if I take one as a 2.5, the half of 2.5 is a 1.25, but then I'll need to make sure that when I minus these, I get a 0.1. Okay, let's see. So if I take x is equals to 1.25 and a 2x to be it's going to be a 2.5. Okay, then the probability of z being less than 1.25 is 0.8944. 0.8944, and the probability of z being less than equals to 2.5 is a 0.99379. 99379. So the probability of z less than equals to 2.5 minus probability of z less than equals to 1.25 is equals to 0.99379 minus 0.8944, which is let me take my calculator out. 0.9937 minus 0.8944 is a 0.0993, which is approximately 0.01. So that wasn't what we were looking for actually, because this is a 1%. The answer said 10%, right? Yeah, so this wasn't a good, this means this wasn't a good try. It should have been something else. Let me, oh no, sorry, actually this rounds up here to actually a 0.10. Yeah, so it is a 10%. Yeah, yay. Okay, so therefore we had what was x? I said, okay, this is what I assumed x to be. So x was equals to a 10 over sigma, and therefore standard deviation is going to be 10 over an x, and then we have an x as a 1.25, so our answer becomes an 8. Okay, but I think like what we should do is that, I don't know, I'm going to think of a better way to solving this, because this requires a lot of like trial and error at this point. So, and strangely enough, the commentaries also say, let me read this out. It just says that the commentary says that look at table 4 and just find two such values, two such z values. So so it's, I don't know, this would take a while. I'm going to think of a better way of solving such a question besides doing a trial and error, because that is quite of time consuming. Anyhow, the last question for this video is question number 9. And it says the life in hours of a light bulb is normally distributed with mean this, okay, mean 200 hours. If a consumer requires at least 90% of the light bulbs to have lives exceeding 150 hours. Okay, so we require the, let's x be the lifetime, okay, in hours. So we require the lifetime in hours to exceed 150 hours. And we want at least 90% of people giving us this answer. Okay, so let's convert it into z. It's going to be 150 minus a 200, and they didn't actually give us the standard deviation this time either. But this is going to be easy because we can use table what was it, table 5 I think. Okay, so this becomes a minus 50 over is equals to a 90%. So if the area above a point is 90, so there, no wonder it's a negative number. So 50 over a sigma, and this whole shaded region is 90. Okay, so remember, due to the symmetrical nature of the standard normal distribution, this 90% area is the same as if we were looking at positive values of z. Okay, so if we have a 90% on the left tail, which means we'll have a 10% here. So now you have two options. Either you can use this, where is it? Where did I write? Okay, the inverse function, yeah. Okay, so either I can use a Excel function, a command, sorry, what am I saying? Excel command. Or what I can do is that I can realize that in table 5, the upper tail probability is going to be a 10%. So when I open the formula sheet and I look at the upper tail, which is given by 10%, I'm just going to look for the value here, and it is a 1.2816. So if this is just directly going to give me z being less than equals to 1.2816, actually greater, wasn't it greater? Yeah, greater is going to give me a 10%. Okay, so therefore this value is a 1.2816. So a 50 over standard deviation is equals to a 1.28. So standard deviation is 50 divided by 1.28, and it's going to give us a 39.06. Okay, this is enough for this lesson. I will hopefully find the time to figure out a better way to do questions like this one. This was a bit tricky even for me, so I'm going to think of a better way to solve this besides doing the hit and trial, and make another video about it. I hope this lesson was helpful, and I will see you in the next one. Take care.